share my screen. Great. Um, so let's talk about what we know about 2025, but I'll preface it with uh, talking a little bit about open source roadmaps. And for Presto, actually, there is no open source roadmap. The reason for this is that road mapping requires central planning, and as an open community, um, that kind of like coordination is just really, really hard. So we actually don't have an open source roadmap, but what we do is we kind of like
Walter, come on.
outsource. I'm sorry. Did anyone have a question? Okay. But what we do instead is we collaborate in a way that kind of like produces something like a roadmap. So what we do is we have project boards to go over what we, kind of like know to be very important initiatives. So some things relate to C++, some things relate to Iceberg and um, the JDK upgrade, which I'll talk about. We also, for major initiatives, what we do is we create what's called RFCs. So as a group, what we do is we create a design document, debate the merits of the design, and then essentially approve it for inclusion in the project. So many of the things that we'll be seeing in 2025 have RFCs, and so you can kind of like check out the design and kind of like the thought process behind each of these features in our RFCs repo. I think you can just Google Presto RFCs. And like that's how basically that's how I know what are kind of like the big things that we'll be looking at for 2025. In addition to that, like we have some things that are really, really important, but don't really quite merit an RFC. So like we have just, some plain old GitHub issues and PRs for those sorts of things. So long story short, we actually don't have a roadmap, but we do know what's important for 2025, and we all kind of like agree, um, what we should be working on. It's just that, like there different folks who come to the project have different priorities, and um, that's okay. That's actually a sign that the project is really truly open. If you have a whole lot of central planning in a project, sometimes it's a maybe like an open source smell for, something's not quite open about that project. So without further ado, we'll talk about what, what I see to be, the really important initiatives that we'll be working on in 2025. When I was putting this together, I kind of like took a step back and thought this is actually a lot of really great stuff. And actually, I'm saying 2025, but actually this is the first half of 2025 because like going back into what I was talking about with roadmaps, we don't know, what we're going to be working on probably the second half of 2025. So a lot of the stuff is either in progress or some of it's already done. It's just we're waiting on a release for it to go out. So we'll be talking about all that. I think the first one that's just really exciting and very long overdue is we'll be upgrading the JDK on Presto. So we have a pending RFC that's open in our RFC repo. Definitely check it out if this interests you. Um, we'll be upgrading at first to JDK 11 sometime probably in the middle of 2025 and JDK 17 by the end of 2025. Um, because we have Presto on Spark though, certain things will get upgraded earlier. So, like Presto on Spark means that Presto is used as a library and, kind of like uses the Spark runtime for execution to give it like fault tolerance and very large batch support. Because of that, we're handicapped on the level of the JDK that Spark itself supports. And as far as I'm aware, Spark right now supports up to JDK 17. Spark, the next major release of Spark, which I think is still in alpha stage, will support later versions of the JDK. So we'll be going in a phased approach where certain portions of Presto, like basically kind of like the core portions, will be on JDK 11 for a longer period of time, but some things like the plugins um, and kind of like the user-facing portions of that will be upgraded to JDK later versions of the JDK. But the long story short is that we should be upgraded to JDK 17 by the end of the year. We'll be moving on to JDK 11 earlier than that. And if you would like to, you can run Presto without Presto on Spark on a higher JDK as well, much earlier. Probably within the first half of this year, if not, kind of like maybe sometime early Q3. So in addition to, what's motivating this work is this is required to address some of the critical CVEs that are, in some of Presto's dependencies. I'll get into CVs in a later bullet, but CVs is a very big, kind of like driving part of this because a lot of Java projects are moving off of JDK 8. And so it's kind of like it's difficult. Whereas in the past it was easy to justify staying on a lower version of the JDK. It's very difficult to justify that now because very, very popular libraries have dropped support for JDK, including Iceberg and Jetty, which are very critical dependencies for Presto. Um, in addition, though, to CVs, you actually get a performance boost just by upgrading the JDK. So we should get a very nice performance boost just by upgrading to JDK 17 for Presto once that's available. And then just from a development perspective, there's nice language features in the coordinator that we can leverage in later versions of JDK. So moving on, performance. So performance will be a very big um, priority for Presto. Some things that we are looking at are just overall looking at TPC-DS performance. Although, in the context of TPC-DS, and I think like we'll probably write something up on this at some point. What we'll be focusing on is what's called price for performance rather than just pure performance. Um, what this means is, like how much does it cost to get you the performance at a certain level in Presto? Um, you know, pure performance metrics, I think are very nice, but I think they lack context, and in most situations, price for performance is a more relevant metric for people who are looking to use a query engine because realistically, you're using it in the context of a data warehouse which costs money. So, like what we're working on is not only overall great performance on TPC-DS, but especially, having great price for performance on TPC-DS so that it's a lot cheaper to run like let's say a TPC-DS query relative to other query engines out there. So expect to see more information on that, later this year. But like we already have really great price performance with C++, but we hope to start to actually measure this and start to publish this information so that, folks can, have this information really easily. But more specifically, we'll be focusing on the optimizer. So there's a master task that was created by Anant where we'll be looking at improving the optimizer to just improve, TPCS queries, which should trickle down to, many different types of analytical queries. In particular, we'll be improving streaming top-in for window queries and also improving our exchange performance. So the exchange performance actually should improve things really across the board. And we're performing an extensive rewrite in VLOX for improving our exchange algorithm. So that's a lot cheaper, and that should, in addition to just improving TPC-DS, it should just improve overall workloads under high contention, which would improve our price for performance, as I mentioned earlier. So lots of exciting, I think, performance enhancements. I think we're looking at all of this in the first half of 2025. I think we should have, some pretty exciting updates later in the half. So moving on, um, we are adding support for function servers. So Presto has for a long time supported what's called function namespace managers. So these allow you to add your own custom, custom functions to Presto, either in process or out of process. So we've had support for that, I think, since about 2020. But what's been missing is an easy way to create a function server. So when you create a function server, kind of like before, let's say 2025, you had to create a function namespace manager, which is a plugin in Presto, and then you had to develop a protocol. So it was actually a significant amount of work to onboard a remote function. What we're working on is the ability to add a REST server that uh, that has a function namespace manager already built. So, like, let's say you have a Python service and you have Python functions that you would like to give to Presto. What you can do is you can spin up a REST server that hosts those Python functions, and those will get registered in Presto automatically. So this should help. I think a lot of cross-language interoperability. You should be able to write C++, Rust, Python remote function servers that all get served in Presto Java. And the opposite is true as well. So if you have a C++ cluster, so you're using C++ workers, you'll be able to actually use Java functions that you might have already built using the Java SPI and serve those in Presto as remote functions. So it's a way to open up interoperability with other languages and also preserve backwards compatibility with previously implemented Java-based functions for C++ servers. So remote functions are, I guess, like you could say that they're getting a revamp. We have a merged RFC, and we've built a lot of this code already for Java. So this should be going out, and I think in the 292 release. And then shortly after that, we should be getting the C++ support. So that should, I think, my guess is that should be coming out in the 293 release. So stay tuned on that. Moving on, we're adding support for Aeroflight. So this one's a very interesting one. So Aeroflight, in case you're not familiar with it, is sort of like an RPC protocol for exporting Aero-based data to other Aero systems. So it's kind of like a standard for exporting Aero-based data. We'll now have a connector template inside of Presto that allows you to write a little bit of code to connect to your specific Aeroflight service and export that as a connector. So you'll be able to query these Aeroflight services in a relatively straightforward manner, just using a kind of like a plugin tool inside of Presto. So this feature is I believe this is already merged. Actually, this was recently merged, so this should be coming out in the 292 release if it's not going to be making it to 291. And so yeah, definitely stay tuned for that. And we're also working on C++ support as well. So you'll be able to query your Aeroflight services from C++ clusters as well. We'll have interoperability for both Java and C++ clusters. We'll at some point, probably in the second half of 2025, we'll be adding support for exporting some of the functionality that existed in existing connectors as flight services so that you can use a previously built connector and export it as a flight service for C++ compatibility. This support should be coming out, I think, in probably the second half of 2025, but that's also another migration path for C++ clusters to use previously built connectors so that you don't have to rewrite the connector in C++. So that one's really exciting. There seems to be a little bit more traction for Aeroflight, and it's also really easy to build Aeroflight SQL support based off of the Aeroflight connector that we've built. So that would open up support for things like Postgres and other things that implement the Aeroflight SQL protocol. So Aeroflight, the Aeroflight connector will be a really nice one. Um, moving on, so we've made a lot of improvements on the user experience for C++ clusters. So I think I probably talked last year about some of the motivations around, kind of like making C++ the default and why we can't do that yet. Well, we've fixed a lot of the problems that kind of like prevented us from doing that. So we now kind of like validate that we're generating correct plans. There's still some planner issues when you use the Java coordinator in C++ cluster. So those kind of like look and feel like like a Java-based planner issue. There's circumstances in Java even where you can kind of like have invalid plans. So we have a plan checker to give you kind of like really quick validation that the plan will succeed so that you can correct it. Could be like an improper session property or something like that. We have functions are now deeply integrated into the Presto coordinator. So, like there's small function differences and some things that are not implemented in the underlying C++ eval. Those can now get trickled up into the coordinator, so they don't show up in show functions. They fail validation in the query if you attempt to use them. Some things like tdigest, qdigest, things like that. And we do support most other functions though, but still, those will get validated. Um, and constant folding support. So we now use the C++ eval to do constant folding in the coordinator. The reason why this is, or you have the option of doing that. The reason why you would probably want to do that if you're using a C++ cluster is there's actually small semantic differences sometimes between the C++ and the Java-based function. So what the constant folding support does is you just end up using the C++ functions for everything. You don't use Java inside of the coordinator and C++ inside of the worker. So this gives you really consistent semantics, and you don't get any unexpected gotchas or correctness issues. You use the consistent semantics between when an expression is constant folded inside of the coordinator and when it's executed inside of the worker. So going up a level, we've made a lot of progress on consistency. So I think overall we should expect to see um, less limitations inside of the Prestissimo on the Presto C++ section inside of our documentation. And we should have, I think, sometime in 2025, like instructions for migrating existing clusters, and we'll probably have a little bit more guidance on when we expect to, move over, shift most of our developer focus to C++ and start to deprecate some of the Java-based evaluation code. So we should have a little bit more clarity in 2025 around all of that. In addition to some consistency improvements in C++ clusters, we're also working on the ability to configure them just the way you can inside of a Java cluster. So, as you can in a Java-based cluster, you can add your own functions, and they're just, built-in functions. They're not remote functions. So they're really fast. They can be used in constant folding. So we're adding the same support in C++. We have a pending RFC, and some of the code's already been written, so we expect to have that, I think, in H1 in 2025. So that'll be very exciting. So you can add your own C++ based, functions inside of your C++ clusters. I mentioned that we'll have support for using previously built Java-based functions via a remote function server. So that support should also be done in early 2025, and we'll be working on a path for migrating existing connectors to Aeroflight also sometime in 2025. This might be in the second part of 2025 though. So a lot more compatibility and migration with kind of like existing Presto code, potentially other systems as well, like Trino, and just kind of like better built-in support for, some of the things that the Java-based clusters did. So a lot of love and kind of like updates on the C++ side, in addition to performance, which is also a very important thing, and where a lot of focus is going. Moving on. So
Hey
we'll be
Tim,
making,
sorry to
yeah,
interrupt.
go for
There
it.
was actually a question on the
Yep.
plan validator.
Yeah. Yeah. Let me
With,
take a look at
with the
it.
plan validator, what happens if a plan is invalid? Is it eliminated for consideration in favor of others, valid plans, or does the query fail?
The query will fail. What the validator does is it fails early so that you don't have to wait until you're done queuing or that you've started to execute. So it'll be like if you try to use an invalid function inside of Presto, or if you like use an unsupported SQL statement, then you get this immediate validation. So that's what the plan checker will do. In practice, it's hard to get it to do that, but if you're in a production, if you're using this in production, it's important because there's just a lot of cases where that can cause a lot of wasted resources, and it's a poor user experience to wait, like let's say until the execution phase to get that information. So um, that like it'll basically just kind of like give you earlier validation that like that you're using an invalid plan. Some examples could be like types. So for example, you're using an invalid type, or certain session properties which we haven't migrated over to hide from C++ based clusters. Those will like fail quickly. Um, so, but in practice, generally you shouldn't use it. You shouldn't use it often, but like we consider this kind of like rounding out the rough edges, so that it's better, kind of like more appropriate for production-based workloads.
I see.
The
Maybe I'll just follow up. So, I understand what you're saying now. So this is actually in some ways an invalid query or an unsupported query. It's not like during optimization you generated an invalid plan and you didn't eliminate that plan or something.
yeah, so yeah, it's more of like an invalid query because um the underlying, like that there are certain cases where there's a mismatch between, like what the Presto optimizer thinks it should be able to do versus what VLX actually does. Um, Over time, most of those things tend to be kind of like hidden behind session properties. So like we'll be moving those over. Actually, I didn't include a bullet, but there was also a separate initiative to just basically hide that so you can't do that. And so over time, we expect to need to do that less and less. But like the what even in Presto Java, you can kind of like construct a query that will just fail, because like you've set like let's say a session property incorrectly, or you've configured Presto in an incorrect way. So that makes it so that those things which depend on knowledge of the eval for that to happen really quickly. They happen in the coordinator so that you know that immediately.
Okay, thank you. That makes sense.
Well, thanks for if there's any other questions, let me know. I can definitely happy to.
Are. Um, okay, as per the point C++ as the default, I'm wondering what is the current state of the art of pipelining Presto to say my own C++ hash join selection aggregation, etc. To what I understand, Presto is yet to become a C++ substitute to Apache calcite plus substrate, Java and Python respectively, complicating integration with C++ primitives.
So when you say your own C++ hash join selection aggregation, do you mean like not using VLOX and just like let's say using your own custom library, or um is that what you're getting at, or did did you have something else in mind?
Sure.
Yes,
Sure,
may
yeah.
I? Okay, thank you. So yeah, I'm wondering, I can make generic functions to take care of primitives for databases, and I'm wondering, I want to adapt them to be able to get to attach them in the end of the pipeline of some object stores, let's say that PrestoDB produced.
So I'm not sure if I understand it yet. So like, w maybe you could kind of like explain it one more time, just because I'm still not. Um, I
Okay,
don't think I'm still following.
there is the process of parsing the SQL, optimizing the query. There is like the process of obtaining the data in different formats, bringing it to memory in some nice view, etc. And now, like having this thing here, now I want to use my own functions to take care of, let's say, the hash join of two tables or whatever, some arbitrary database operation. Can I really use my functions there, or that's yet another, I don't know, or already PrestoDB integrates its own, and pipelining this part of execution is something non-trivial there, and I should probably stick to cow site or substrate.
Well, if you're talking, hash join is like a fairly generic thing. So if you're talking about the functions that are used within the hash join, then we will be able to support that. So like right now you're kind of constrained to the set of functions that have been implemented in vlocks. Like what we're like what we're doing is we're allowing you to just bring your own functions so that you can use your own functions that are used that can get kind of like used by hash join to determine if there's a match between the build and the probe side. If you mean like a custom implementation of the hash join algorithm, like what you're that is considered a core operator of SQL. And so, you can do that too. That's a lot of work. But like that, that could be possible. Um, but the presumption is that the implementation that has been built inside of vlogs is just about state of the art if you're using a CPU based architecture. So, like you might not there might be some diminishing returns. If you're using like like you could use a GPU or like a some other based some other type of approach, and like we do have vendors who are exploring and working with vlocks and adding that support. um and so like you could kind of like explore that approach as well, but typically the approach is to kind of like work within vlocks instead of swapping it out entirely.
Actually, exactly. My use case would be to try out some hash joins on GPU, in CUDA specifically, and I was wondering, yeah, like I really wanted to check out with C++, but of course, like I assume that you're already using state of the art. But I assume that, okay, so to what I understand, swapping is possible already, I suppose, with what we have, what there is in master. I should be able to create those pipeline executions.
Yeah. Let me maybe kind of like we can talk after the meetup and maybe discuss that in depth, and I can kind of like give you some pointers on how you'd go about that.
Super amazing.
Yeah. Cool.
Thank you very, very much. Thank you.
Yep. All right. So I'll move on. Just have a few more updates, I think, relevant. Um, So we'll be spending a lot of like we did a ton of work on Iceberg in 2023, 2024. I'm fairly happy with our level of Iceberg support at this point, but like there's still a lot to do. Um, so I think some of the most exciting ones that I think we'll be adding for Iceberg are update and merge. So update, we already have an open PR, and we should actually we should get that merged fairly soon. So we should be looking at, I think, probably around 292 for update support within Iceberg. Merge support is being worked on. I expect that to, arrive somewhere around, sometime in 2025. But that'll be a very nice one as well. Merge gives you this very flexible syntax for, kind of like updating or replacing rows and merging two different tables. It's very important for CDC-based workloads, so merge support will be a very nice addition as well. Another enhancement is manifest file caching support for Hive. So we already support manifest file caching for other Iceberg catalogs, including Nessie and a few others, but we don't support it for Hive or Hadoop. So we've built that support for Hive. I believe this works on Hadoop as well. And so this should improve the performance for point queries substantially. So like I think one of the problems with Iceberg that a query engine needs to address is that when you load an Iceberg table, that involves perhaps hundreds of different files that you have to read to kind of like do the scan planning. So manifest file caching comes in handy to reduce that time substantially. So manifest file caching already also has a PR open for that, and we did see some really substantial improvements on our Iceberg performance that basically kind of like brought us almost on par with Hive, which is very, very exciting because Hive, we spent years making that very fast. Sorted writes and reads. So we also have an open PR for sorted writes and reads that also should get merged pretty soon. So I think we're looking at 292 for that. This is useful if for selectivity. So like if you do a sorted write on a file, and then like you have a filter on that column that you ended up sorting, it can make it very performance efficient because like you can skip a lot of the manifest files, and then even within the files themselves, you can skip a lot of the row groups inside of the Parquet files. So this helps with selectivity, selective reads. And then overall WAP workflow support. So this is, Iceberg has this concept of branches and tags. In Iceberg, you can, kind of like tag a table at a moment in time for like, let's say GDPR purposes, auditing purposes. So we'll have the ability to tag a table so that you can just kind of like preserve the table at that moment in time. And you'll have the ability to branch it. So like you'll have the ability to create a branch off of a table for testing purposes. Let's say insert some data, test to see if it worked out well, and then commit your change. So branching and tagging, and then kind of like all of the DDL and all of the tools required to support that will be added, which is a very nice and welcome addition. And we expect to have materialized view support, or at least we understand that this is a very important thing that we need to add. And I expect us to get to this in the latter part of 2025. I would be surprised if we don't. We do have the Iceberg community seems to be coalescing around a materialized view spec. So we hope to leverage that and not kind of like build something custom and kind of like build a solution that works with Presto SQL. Cool. And this is not, so I think like there's a few additional Iceberg enhancements that I think are probably important, but I just, I didn't think I could fit into one talk. So overall, Iceberg, there's a lot of focus on Iceberg, both performance and features. So we should be just, getting a lot of updates overall for the Iceberg connector in 2025. Security. So we have actually been spending a lot of time the past few months, and we expect to continue this for the next few months on just, addressing various different CVs that are, found within our dependencies. So I think we've addressed a large amount of the criticals and highs, but we should be able to, our goal is to get rid of all of the criticals and highs in 2025. So there's a lot of ongoing work to just plug up all these gaps and close these CVEs. And you'll find that in our release notes we have we call these out, so you can start to take a look at our release notes to see the various different CVs that we've closed thanks to this work. And then finally, this is one that I'm actually very excited about, which is the Presto router. So the Presto router allows you to run multiple Presto clusters and load balance queries in between the clusters. So, this becomes really necessary as soon as you grow really beyond the size of one cluster, or you want some redundancy or, failover. Presto does support disaggregate coordinators, so like you can support like a coordinator crashing, but the resources behind those coordinators are still kind of singleton. So, like a truly robust strategy would be to use both. So you'd want to probably have a load balancer in front and then several clusters that sit behind the load balancer for resiliency, kind of like rolling upgrades, things like that. So we've had the Presto router for a few years, but we'll be adding a lot of core functionality to the Presto router to make it more enterprise ready. So number one is some security improvements. So it'll now support, I think, token-based authentication, JSON Web Token authentication, I think. So in addition to that, we'll also support plugins. So we'll be able to add plugins to configure the load balancing algorithm so that, let's say, if you have a custom metric that you would like to load balance on, you can implement a plugin to read from that metric and influence the load balancing on the Presto router that reads your custom metric. So I think for any enterprise, like you would probably have something that the open source router doesn't know. So that kind of like allows you to configure it to do exactly what you need. And then finally, we'll have better metrics for monitoring and just overall hardening improvements. So I think the Presto router by the end, actually within the first quarter of 2025 should be getting a lot of major enhancements that will make it, I think, a lot more attractive for enterprises. So I think a lot of this love is really needed just because for large Presto deployments, you need something like the Presto router. And so, for it to not have, like these features, in my opinion, kind of like make it a more suitable out of the box solution for that sort of thing. Cool. And there's a few other improvements, including, like we'll be adding a dedicated SPI for row filtering and column masking. We've supported row filtering and column masking for quite a while with the connector optimizer framework. But like now we have essentially we'll be using the something that's mostly compatible with the Trino SPI. So if like it should be easy to port a Trino implementation of the row filter column masking plugin into Presto, so that can be used within Presto. And then we're also adding some open telemetry support so that it'll be easier to troubleshoot Presto clusters and specific queries that might be slow. So there's quite a lot. I think like some of the I think highlights are performance, security, and then working on C++ so that it can be used kind of like in more production environments by plugging up some of the gaps and that it has with Java. So a lot of exciting work, and then also interoperability. So like both through remote functions and integration with Aeroflight, there's a lot of focus on interoperability and supporting more clients. So yeah, I think that's what I found. There's a lot going on with the project, so it's good to pay attention to the RFC's repo. There's usually we'll have an RFC at least once per month. They tend to be interesting things. So definitely take a look at that. And we talk about all this stuff at the TSC meeting. So TSC meetings are good to drop in and just learn about some of the stuff in depth. And I think that's all I had. If there's any other questions, I'll be
Um,
happy to answer them, or we can.
One other
Okay.
question that came in, does it support .NET development? Can this be coupled with Azure?
You can, so by coupled with Azure, does this mean like deploy Presto servers in Azure and then use um I'm forgetting the name, but like Microsoft's cloud storage?
Kate, I don't know if you're here, but you can go off mute if you want to elaborate.
Yeah, sure. Thank you. Thanks, Ellie. So my question is, actually, I'm a .NET developer, and we have a solution in the Azure as well, and we are targeting more on the moving our data, current data into the Azure systems, and like to leverage more on the Azure data lakes and data bricks as well. So if we are proposing any solution for the Presto, how it will be useful, and how it can integrate with our .NET APIs that we are implementing in the .NET Core. I hope
Um,
I can, or you want me to elaborate more on my question?
yeah, I think so Presto operates Presto's connectors can operate over arbitrary data sets, and but we have a lot of really solid connectors that work over kind of like table formats. So if you have a data lake inside of Azure that uses Iceberg or Hive, Presto should be able to support that. I know that we did some work to support once again I'm forgetting the name, but like Microsoft's cloud storage protocol. I believe that that's all done, even in C++. So like I don't think that you should have trouble getting that to work. If you're talking about kind of like let's say .NET services that need to be
Mm-hmm.
exported through Presto,
Mm-hmm.
you should be able to write a connector that that exports that, so that it can, like, let's say join with other data inside of a Presto cluster.
Great.
Does
So
that answer your
is that
question?
something like we consider the deployment aspects, like post deploy development, if we want to deploy that. So on the production environment, is that something like we need to create a separate platform for the connectors, or it can be easily integrated with our own solutions?
If you're if you're using like as I mentioned, some of these connector support in C++ is still a work
Mm-hmm.
in progress. If you're using a Java-based cluster, then that's easily supported through a plugin. So what you do is you write a plugin that does this integration with your data platform, whatever
Mm-hmm.
services you've written in .NET, and you put it in the plugins directory of Presto, and then Presto will read that and register it and can read, read data from those data sources. So there's a little bit of code that you need to write for Presto to kind of like find it and understand, but like that's possible just using the plain old Presto SPI.
Sounds great, Tim. Yeah, that's all I have. Thank you so much.
Yep.
All right, any more questions before we wrap up? Cool. Thanks, Tim. I think that was really helpful. So we did record this. We will post it, and appreciate everybody that attended and asked questions. This is really great. We have a few more events coming up, as I shared at the beginning, so please feel free to join us for any and all of those. We'll also be doing these meetups monthly, so keep an eye out for our next set of topics. Thanks, everyone. See you later.